Hello, and in this video I'll be talking about the roots of polynomials. This is a part of the algebra and series topic in A-level further maths. Considered to be one of the easier topics, but still, it's a must to know how to do these types of questions. So, this sort of builds upon knowledge that you've all come across in A-level normal maths and GCSE maths as well, to some extent. So we've all seen a quadratic before, ax squared plus bx plus c, right? And we've all worked out the roots or the solutions to this quadratic as well in the form of alpha and beta, right? So what we need most for this topic is to figure out the relation between the coefficients of a polynomial, whether that be a quadratic, cubic, quartic, right? And its roots. They're related. So based on GCSE maths or A level maths, you might already know that the sum of the roots of the quadratic are minus b by a, right? So b being the coefficient to x and a being the coefficient to x squared, right? And the product of the roots is c over a. And also, like this is how we factorize, or this is how we're taught to factorize things in GCSE maths, especially. Oh, the last number is going to be the product of the roots, and the middle number is going to be the sum of the roots, especially when the coefficient of x is 1, right? And that's how we factorize. But actually, you can take this and extrapolate it to higher order equations like cubics. So in this case, the general cubic would be ax cubed plus bx squared plus cx plus d, right? And its roots will be alpha, beta, and gamma. All you need to know is that when it's all of the roots being added together, right, it's just b by a. So when it was all of the roots being added together in, I hope it's still recording. It is, I think. Okay. So when it's all of the roots being added together, alpha plus beta, there's only two roots in a quadratic, it's also minus b by a. Similarly, when it's all of the roots of the cubic being added together, it's minus b by a. When it's pairs of roots, so quadratic only had one pair, alpha beta, is c by a. But when it's a summation of pairs of roots, then it's c by a. And then when it's the summation of all of triplets of roots, in this case there's only one triplet, alpha, beta, gamma, it's minus d by a. So you might see a pattern. It starts off minus b by a, then c by a, then minus d by a, then e by a, then minus f by a. You'll never actually have to get that far in an actual question. At least I've not come across any questions where you have to get that far. But yeah, the pattern is it starts off negative, positive, negative, and also just keeping in mind how many roots. So in the first case, minus b by a, you're always adding all the individual roots together. Then you're adding pairs of roots. Then you're adding triplets of roots. And then you'll be adding quartets, if that's even a word. So in a quartic, just to sort of drill this into you further before we do a practice question, right? Single pairs, roots being alpha, beta, gamma, and delta, right? Same thing, minus b by a, where ax for bx cubed, cx squared, and d are the coefficients, right? Pairs of roots will be c by a, triplets will be minus d by a, and oh, sorry, just meant to be dx. This is why I was wondering, like, why is there only d? Because there's a d here, right? And then the quartet, or the product of all the roots in this case, will be e by a. Cool? And so on and so forth for even higher order equations. You can get some pretty interesting questions. So in order for you to get familiarity with this, I've pulled up an example question. You tend to need some space. That's why I'm doing some more not on PowerPoint. So let's have a go at this question together. And if you can do this question and you understood all of the previous part, you'll be absolutely fine with this topic. Okay? So you're given the roots of a cubic that are alpha, beta, and gamma. The first part of this question is that you have to write down the cubic equation with roots, which is alpha minus 2, beta minus 2, and gamma minus 2. This is a very general question. I've seen this come up on a lot of past papers before, right? And actually, it's it's a lot of algebraic working out, but I don't tend to find these types of questions too difficult, right? So firstly, let's extract information from here. I'll do an orange. Let's extract information from here, right? So because the roots are there, and this is our cubic, we can know that alpha plus beta plus gamma is minus b by a, which in this case is just 2 by 1, right? And the pairs of roots, so alpha beta plus beta gamma plus alpha gamma, is c by a, which is minus 1 over 1, and the triplet alpha beta gamma is d by a, which is 2 over 1 again. Cool. So firstly, let's just establish these, and then you start to work out, right? You can sort of backtrack. So far we've been using the solutions to the roots to figure out minus b by a minus c by a. You can actually backtrack as well, right? So if the roots were to be, for example, the sum of the roots, alpha minus 2 plus beta minus 2 plus gamma minus 2, or actually, you know what, I'm going to do the next quadratic. This is for the first quadratic. Let's do this for the second quadratic, right? So for this quadratic, alpha minus 2 plus beta minus 2 plus gamma minus 2, right, will be minus b by a. Let it be ax cubed plus bx squared plus cx plus d. So whenever I'm saying b by a, I mean this cubic that we're trying to work towards, right? So already you can tell, right? It's alpha plus beta plus gamma minus 2 minus 2 minus 2 minus 6 equals minus b by a, right? We already know what this is from here. So we already know 2 minus 6 equals minus b by a. Therefore, minus b by a is minus 4, right? Keep this in mind for later. Cool. Now, similarly, you will have to do alpha, beta gamma, and alpha gamma. So we're taking the products of these. Let's move this aside. Plus alpha beta minus 2 alpha minus 2 beta, right, plus 4, and it's going to be the same thing, right? Then it's going to be alpha gamma minus 2 alpha minus 2 gamma plus 4, and it's going to be gamma beta minus 2 beta minus 2 gamma plus 4. So in total we're going to get minus 4 alpha minus 4 beta minus 4 gamma, right, plus 12. So it looks like alpha beta plus beta gamma plus gamma alpha plus, minus 4 alpha plus beta plus gamma plus 12 equals c by a, right? And we know that alpha plus the pairs are here, right? This is nothing but minus 1. So minus 1 minus 4 times 2 plus 12 equals c by a. Therefore, c by a equals, so minus 8 plus 12 is 4 minus 1, 3. Cool. C by is 3 minus b by is minus 4. And the last one, I'll just do it to the side quickly, right? Is when you multiply all the roots. So you'll do alpha minus 2 times beta minus 2 times gamma minus 2. Right, so it'll be alpha beta minus 2 alpha minus 2 beta plus 4 times gamma minus 2. Right, so it's going to be alpha beta gamma minus 2 alpha gamma minus 2 beta gamma, right, plus 4 gamma, right. I'll put this in the second line, so it's going to be minus 2 alpha beta minus 4 alpha minus 4 beta and minus 8, right, equals minus d over a. So as you can see, this is by itself. We got one alpha gamma, beta gamma, and alpha beta. And then these are the individual ones, all with a coefficient of 4. Is this one really plus 4y? It is as well. That might be a little bit problematic actually. Will it be? Okay, let's go with it. So we will get alpha beta gamma minus 2 alpha beta plus beta gamma plus alpha gamma, and ideally it'd be minus 4, but it's not, is it? So you get alpha beta minus plus 4 minus 2 alpha beta gamma 2 alpha gamma 2 beta gamma plus 4 gamma. Oh wait, this is plus 4 as well, right? And this is plus 4 and this is minus 8. That makes a lot more sense, right? I was worried for a second. I was like, oh, where have I gone wrong? Because it's minus 2 times minus 2 alpha. So it's plus alpha beta gamma minus 8 equals minus d by a. And as you can see, the same old trick, you just substitute. So alpha beta gamma we worked out to be 2, the pairs is minus 1, and alpha plus beta plus gamma is 2 again. So this is nothing but 2 minus 1 plus 4 times 2, right? Yep. Minus 8 equals minus d by a, right? So plus 8 minus 8, this is plus 2 plus 2, so 4 equals minus d by m. So if we just assume a to be 1, right? So if a equals 1, then b equals 4, c equals 3, and from here d will equal minus 4, right? Therefore, our cubic, or the answer, the new cubic, is x cubed plus 4x squared plus 3x minus 4. It's quite different to what we started off with. But yeah, in this type of question, all you will end up doing is, if you get given, like, if you're finding the new cubic with some sort of relational roots, you take it, you firstly find out these 3 or 4, like, known alpha plus beta plus gamma. Then you find out what the sums and products of the new roots are, and always they will always group to be something like this, where you can just substitute for the old pairs of roots or single roots or triplets of roots, right? And you sort of reverse engineer your way to the cubic. Okay. At the end of this question, part B, for the new equation, so the new equation was here. No, actually, I'll just rewrite it. So the new equation, x cubed plus 4x squared plus 3x minus 4 find that. Okay, so immediately I can tell when I expand out these three brackets, I will probably get something quite favorable, which I can just plug in, right? So let me choose another color to make it very distinct again. Let's go with green, actually, for this. So this is looking like alpha, beta, gamma, right? And then let's expand out these two brackets first, okay? So I will get 1 plus alpha gamma plus beta gamma plus alpha beta gamma squared, right? And then this is alpha beta times again. So timesing these two now, I will get alpha beta gamma. Okay, I'm going to times everything by 1 first, then I'm going to times everything by alpha beta. Okay, so 1 plus alpha gamma plus beta gamma plus alpha beta squared, beta gamma squared, right? I'm going to go to the new line. It's going to give me plus alpha beta plus alpha squared beta gamma plus alpha beta squared gamma plus alpha squared beta squared gamma squared. Which is quite interesting. Okay, so now if you've seen the pattern already, right? So outside the brackets we have alpha beta gamma, which we already know, right? Alpha beta gamma is d by m, or minus d by m, rather. Did I do that? Oh, this is minus 2. I messed up in the first one, right? So here, this is minus 2. So d by a is just 0. So there is no d. D is 0. So that's our new equation. Cool. Okay, so d by a in this case is also 0, right? So, oh wait, no way. So therefore it was a case of 0 times the brackets all along. The answer is 0. But for the benefit of the doubt, because this is a very common question trope, right? Let me show you how do you actually simplify this inside the bracket. The final answer is 0, right? But inside the brackets is actually 1 plus, right? I'm just going to add my own brackets. Alpha gamma plus beta gamma plus alpha beta, right? This is obviously our pairs of roots, right? Plus, if you notice here, right, every single one of them has an alpha beta gamma in common. So this is an alpha beta gamma, and then this one's left with an alpha, this one's left with beta, and this one's left with a gamma. Plus beta plus gamma, right? Again, a second sort of pairing. And the last one is just alpha beta gamma squared. And as you can see, again, we've broken everything down into what we can sort of derive from the coefficients. But as we know, alpha beta gamma equals 0. So the whole answer in this case is just 0. And if I didn't mess this one up, again, easy mistake, it's minus b by a, right? This is minus b by a, and this is minus d by a. This is c by a. I would have just looked at this question, figured out alpha beta gamma was 0, and not even done any working. But I'm glad I did, because again, this is a very common expansion that you will have to do at some point in your A-level further maths career. Cool. With that, if you want to see more questions like this, I'm going to upload another video further on this week, just going through loads of different A-level further maths algebra and series questions, so keep an eye out for that. I hope you enjoyed watching. Thank you.